The topic we're going to study here is arithmetic and geometric sequences. You may look at these as simply patterns, which is exactly what they are, but because they have a specific characteristic, they get a name that goes with it. Let's look at arithmetic sequences first. An example of an arithmetic sequence is the one you can see. It starts with 3, then goes to 14, then goes to 25, and continues on in that fashion. This pattern is not a very difficult one to see. As we go from 3 to 14 and from 14 to 25, we can see that the number is increasing by 11 each time. When this happens, when it increases by the same amount each time, this is called a common difference. And it is this common difference that makes this an arithmetic sequence, when they go up by the same amount each time. You can look at this and say, well, it goes up by 11 each time. What would the next number in this sequence be? Well, it would be 11 more than 25, so the next number in this sequence would be 36, and that would be correct. However, if I asked you, what's the 23rd number in this sequence going to be? Well, one approach would be to list them out all the way till you get to the 23rd number. That's not that practical, especially if I ask you for the 400th number. So what we're going to do is come up with a formula that will give us any term we want out of a sequence. And here's how we're going to do that. N equals A plus N minus 1 times D. Don't get freaked out by the algebra look that this has to it. It's really not a very complicated setup at all. What we've got here is N is the nth term, and what that means is it the 20th term, is it the 61st term, is it the 138th term? Well, whatever it is, it's the nth term. We can find any term using this formula. A is going to be the number where it starts. D is going to be that common difference that we mentioned before. So D is our common difference. And this part here, N minus 1, a lot of times students have a question about that. Well, I tend to think of that as, how many jumps do you have to make? Here's what I mean. Let's say we wanted the 4th term of the sequence we were given in this problem. And now, in this example, we know the 4th term is 36. We already found it. I understand that. But if I want the 4th term, and I start out here, how many jumps do I have to make to get to the 4th term? We'll have to make 1, 2, 3 jumps. That's how many jumps I have to make to get there. If I want the 4th term, I make 3 jumps. If I wanted the 7th term, I would make 6 jumps. And so basically what we're saying here is, you've got your starting point. How many times will you have to use the common difference to get to the nth term? And so that's what the n minus 1 is. Frankly, the n minus 1 is just going to be a part of our answer, so you're not going to have to change that when you write the formula for the nth term. Let's finish this thing up. So we've got our general formula for an arithmetic sequence, which is n equals A plus n minus 1 times D. In this case, we're looking for the nth term, so our formula is going to be n equals, A is our starting number, that's 3, n minus 1 is just going to be a part of our answer, and then D is the common difference. How much does it change each time? And that's 11, so 11. So a formula for the nth term of this arithmetic sequence is right here. N equals 3 plus n minus 1 times 11. You might think, well, shouldn't I go ahead and simplify that and use the distributive property to multiply the 11 through those parentheses? And well, you can, but honestly, people get more information about our sequence when it's in this form. Because in this form, I can see where it starts, I can see what the common difference is. If you simplify it, that information won't be as easily seen. So it's better just to leave it the way it is. And the value of having a formula like this is, let's say I wanted the 17th term. So if I want the 17th term, Well, I know that's going to be 3 plus 17 minus 1 times 11, or 3 plus 16 times 11, which is 3 plus 176. So the 17th term of this sequence would be 179. I can use that formula to find any term I want. Now let's look at geometric. In this geometric sequence, we sure can see that the numbers are getting big awfully fast. That's because unlike the arithmetic sequence, where we have a common difference, in this case, instead of adding or subtracting the same amount, we are multiplying by 7, multiplying by 7. So we're multiplying or dividing, but in this case multiplying by the same amount, and that is called a common ratio. Instead of a common difference, now we have a common ratio. If we want a formula for the nth term for a geometric sequence, the formula that we're going to start with is, again, n equals a, which is familiar. A is just the starting point, times r raised to the n minus 1 power. This is very similar to the last one, really. A is, again, our starting point. R is our common ratio. And again, n minus 1, that's how many times do we have to do it. In other words, I've got my starting point and I'm going to multiply by r, and what this tells me is how many times you're going to have to multiply by r. If I want the 20th term, I'm going to have to multiply by r 20 minus 1, or 19 times. So that's what the n minus 1 is in there for. Very similar to the one we did before with the arithmetic sequences. Let's take a look and see if we can find the formula for this geometric sequence. So let's plug in the stuff that we're after. The nth term will be the starting number, which in this case is 8, multiplied by the common ratio, which, how much did I multiply by each time? Oh yeah, that was 7, times 7 raised to the n minus 1. My formula for the nth term for this geometric sequence is 8 times 7 raised to the n minus 1. And let's say we wanted the 5th term. We would have 8 times 7 raised to the 5 minus 1, which is 8 times 7 raised to the 4th, which will be 8 times 2,401, which altogether will be 19,208. And so the 5th term of this geometric sequence would be 19,208. Again, if you wanted the 30th term, this formula would work. Be an awfully big number. The main thing is, if we're looking for the formula for the nth term of a geometric sequence, it's going to look something like that.